T-minus 1 minute. T-minus 30 seconds. We are go for launch. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Welcome to the NASA Social for the Mars 2020 mission. The countdown is on.
Welcome, everybody. Welcome to the Countdown to Mars virtual NASA Social. I am your host, Yves Lamoth. I am with the Exploration Ground Systems, Comm Systems Project Manager. And with me today is the one and only Maddie. Maddie, how are we doing today?
I am great. It is always a pleasure to be here with you,
Oh
Yves.
my gosh, you know, if you're great, it means I'm great, so let's make everyone else great, right? So talk to us a little bit, Maddie.
Perfect. So we're going to have two very special guests joining us today. And while you're watching, we're encouraging you to drop your comments either in the YouTube chat, the virtual NASA Social Facebook group, or on Twitter using the hashtag #CountdownToMars.
Awesome, fantastic. So again, folks, we are here to talk about the Perseverance mission, right? At NASA, we're always doing, exciting things. And with us today, we have Dr. Z. Dr. Z is an associate administrator for the Science Mission Directorate, and he's going to tell us a little bit about his role and what he does in regards to the Perseverance mission. Dr. Z, how's it going today?
I'm doing well, Yves. How are you?
I am doing fantastic. Thanks again for being here with us.
Oh, I'm so excited.
So please talk to us. This is such an exciting moment, and I know our guests are, very envious to learn all about what's going on here.
Absolutely. And I'm so excited to have all these social media friends all over the world with us. This truly is an international view that we have here. Like so many of these instruments were built in other countries, France, Norway, and in Spain, for example, and we're really working on this. So my job, you asked what it is to lead NASA's science program. So as part of that, we have about 105 missions that we're currently working on. And I can tell you some of these missions are absolute classics. You know about the Hubble Space Telescope.
Oh, yeah.
You know, of course, about Curiosity that's already there. You know about the Parker Solar Probe. And you know about some of these amazing Earth science missions that are, in fact, even now, today, providing information that improves and protects life on Earth. So we have a broad set of portfolios. This mission is really a jewel in it. I'll tell you what's special about it. Mm-hmm. Now, one of the questions we're really focused on in all of science, not just in planetary science, but in all of science, is the question that people have asked for thousands of years, which is there life elsewhere? Philosophers have asked that. There's books full of it. Well, we're ready, we believe, to start answering that question with missions that are focused on astrobiology. Wow. Focused on that question. This is NASA's first astrobiology mission that we have done for many, many decades. I would argue that really since Viking, we're ready now to ask that question, is there life elsewhere, based on the work that happened before. By the way, there's others behind it. The Dragonfly mission to Titan is another. astrobiology mission. And frankly, many of the other missions, even telescopes that are looking at planets like James Webb, have astrobiology contents that are part of that, like looking at atmospheres of exoplanets. So when I look at this, I think of that question and the importance of asking that question now, today, in 2020, as we go forward.
Wow. Wow. So I mean, just with that alone, I already have 1,000 questions in my head. But before we do that, Maddie, do we have any questions from the audience yet? I don't want to take all the time or anything like that.
Yes, we do. So first question from social media is, how does Perseverance differ from Curiosity in the types of science it will perform?
Love that question. So Curiosity was really the mission, the first mission after Spirit and Opportunity. Remember, Spirit and Opportunity had one kind of objective, which is to follow the water. You look at Mars, you think, hey, some of these things almost look like channels. Was there water? Well, it's actually easy to ask that question, really hard to prove that it was there. You have to go land and look at it. And what we found is not only was there water there, the signs of water were everywhere, like river deltas, kind of microscopic structures that look just like some of the things on Earth. And so what Curiosity did is it went there with instruments that are really amazing, still the best instruments that have ever been on Mars looking at that, such as mass spectrometry, looking at molecules that were there, basically saying, what do we have any of the organics? So we have water, which is a major ingredient. Do we have complex chemistry, which is another one? Together with energy, there's one of the key ingredients for life. And the answer is yes, with an exclamation mark, just like water, yes, with an exclamation mark. And now what we're now doing is basically saying, okay, so now we know that. Now we're ready to ask the direct question, is there life there? And the instruments that we have there, frankly, are there to equip us to get the right samples. All the instruments, whether it's the ground-penetrating radar, whether it's the cameras, whether it's the spectrometers, are getting us ready to pick the right samples. Because what we believe, that question about life, needs to be answered with the best labs available to humanity, not the best labs we can put on our rover. The best labs available to humanity, which are the labs right here. So we're going to bring it back. And in 26, we expect to launch right from here, I'm sure, with a launch vehicle in it. It's preparing humanity's first launch of another planet. So we're going to land there in 27 or so, and then in 29 or so, we're going to take off the surface of Mars with that rocket and then bring those samples back. And in early 31, we'll have them here, and we're going to answer that question with the best lab. So we're preparing for that 10-year-long exploration, and Perseverance is really the start gate for that.
Wow, amazing. So can they talk to each other? Can Curiosity and Perseverance, are they able to communicate with one another?
If they had a reason to say hi to each other, the way they would do it is to go up into orbit with one of the spacecraft going over it, and then down to them, to the other one. They're in very different regions. If you look at that, very often we forget how big Mars really is. So if you took all the ocean away from the Earth and just look at the landmass, and you compare the landmass of Earth with Mars, it's roughly the same. Wow. So in other words, one of them is, if you want, in Asia, and the other one is in North America, right? Very far apart from each other, right? And so that's how you should think about Curiosity and Perseverance. So they could, if there was a good reason for it, but
right now they're on separate missions.
Exactly right. And we're, by the way, Curiosity, we're still pushing the envelope at that. Make no mistake. Just like how we've kind of done Spirit and Opportunity, do the best of our ability, kind of squeeze all the science out of it. And there was a lot of science there. We're still doing the same with Curiosity, as well as some of the orbiting assets that we have also.
Amazing, amazing. What else do we have from the audience, Maddie?
Yeah, so we'll do one more question from social. How did you prepare the rover for the harsh conditions on Mars?
Yeah, this is a really good question also. And it's one of those things, the way we prepare it is to run them through the ringer. I mean, we beat them up, we shake them, we heat them, we cool them, we do everything that we can. We, blast sound at it at a volume that's very, very high. So everything is ready to the best of our ability to go there, even testing in the dirt, right, of kind of quasi-vacuum, just like Mars, and making sure that everything works exactly like it should. So this rover sitting on top of this rocket has persevered. It has persevered a lot of testing, kind of to the extent that, frankly, pretty much no other spacecraft has, because it has to survive launch, the cruise in vacuum, and then operation in the Martian atmosphere, which are really three totally different environments.
Mm-hmm.
Wow, amazing. So, I mean, in just this little short bit, I think I've learned so much about the mission itself and the capabilities of this beautiful machine. Are there any final thoughts that you want to leave us with for today, Dr.
I
Z?
really appreciate that. So when I look at this rocket and I saw it roll out yesterday, I remember, of course, that the rover is called Perseverance and the helicopter is called Ingenuity. But what I want to just tell everybody is that I also remember, and I think we all should remember, that with these vehicles up there is the perseverance and the ingenuity of thousands of people, individuals that gave their all, their sweat, their tears, to make sure that we're ready for that. And I think when we see that launch tomorrow, we need to remember that it's for them, for their sake, that we're actually able to do this launch. This was very hard to get ready, especially in the time we're in, but it's the perseverance and the ingenuity of each one of them that got us there. So thanks for that.
Dr. Z, that is such a beautiful message, because to me, what I'm getting from that is, as a people, we will persevere, right? We will explore this beautiful landscape called space, and we'll find out exactly what we have going on there. And speaking of perseverance, guys, let's take a closer look into what this mission is all about.
We are a species of explorers, believers.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard.
We are willing to do the hard things, to overcome the many challenges. This is what brings out the best in us.
We go for a mission to the moon.
Our path has led to success and to bitter losses.
We come together today to mourn the loss of 7 brave Americans.
Yet, even when faced with tragedy and setbacks, we persevere. We keep striving. We keep believing. From space, we see our planet as a whole. We see the challenges facing it, and we face those challenges together. We will not give up. We challenge convention. We refuse to accept the status quo. The time at hand is hard, but we will persevere. We can still draw hope from the moon and the stars, from space, from exploration. There is a new day beyond the challenges we face now.
Guidance internal.
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans.
10, 9. We have ignition sequence start.
But if rovers are to be the qualities of us as a race, we missed the most important thing.
3, 2.
Perseverance.
Launch commit. Liftoff. We have liftoff.
We are a species of explorers. We will meet many obstacles on our way to Mars. But as humans, will not give up. We will always persevere.
Welcome back, folks. We hope you enjoyed that little snippet into what's going on with the Perseverance mission. Once again, I am your host, Yves Lamoth. I am with the Exploration Ground Systems Comm Systems as the project manager. And we're back here again, and this time with us is Dr. Lori Glaze. Lori, how's it going today?
It's great. Excitement is growing.
It is great. I mean, we're already excited about everything that Dr. Z had to say, and I tell you, I bet we can sit with you guys for an entire day, and it wouldn't be enough just to get more insight into what actually went into making all of this happen. So can you tell us a little bit about your role in the Perseverance mission?
You bet. So I'm the director for the Planetary Science Division at NASA, and what that means is I oversee a program that develops spacecraft, but also funds and supports a lot of science research that's all focused on trying to answer really important questions about how the planets and how the solar system formed, how it has evolved, and trying to understand what types of environments where life might form, which is the field of astrobiology, understanding those environments, understanding how life comes to be, and whether or not it can be sustained in various places.
So are you saying you're going to be gods, figure out how to create life?
I didn't say we were going to create it. I said we're trying to understand the environments where it can form and the environments where it can be sustained.
That is truly an amazing feat, and I bet it's exciting, all the things we can learn. So I want to get right into the questions because I know our time is limited, and I know our guests are chomping at the bit to get their questions answered. So Maddie, what do we have?
Yeah, so first question is, how does the rover search for signs of past life?
That is an absolutely great question. So one of the things that it does is it's carrying multiple instruments, which I think Dr. Z mentioned a few of them. We're carrying an instrument called Sherlock, and an instrument called Pixel, and an instrument called SuperCam. And those three instruments together are a fantastic, very sophisticated suite of spectrometers that can look at the chemical makeup at a microscopic scale on the surface. And so they're going to look at the minerals that are present, the rocks and the minerals, and they're going to measure the chemistry. They're going to understand or help us to understand what elements are present there. Are the building blocks for life present? The hydrogen, the carbon, the nitrogen, the oxygen. Are those elements there? They're going to look for other types of biosignatures, looking again at that chemicals that are present in those rocks. And they do it in different ways, each of those instruments. And that'll help us put together a picture, a puzzle that says, are these the right pieces that you need, those building blocks to actually put the things that form life, the things that we've seen, at least on Earth, that come together to result in life. So that's what we're going to be looking for. And as Dr. Z said, we'll use that information as we find those places that have those signatures, potential biosignatures, to guide us into the places where we want to take those drill samples and actually get those precious samples back here to study.
Okay, so I want to ask a somewhat simple but complicated question, and it is, being that there's atmospheric differences between Earth and Mars, is there a concern as to how those samples you collect would behave on Earth versus in their natural element, which would be Mars?
That's actually a really good question, because you're absolutely right. They've existed here in a carbon dioxide atmosphere on Mars for billions of years, and certainly if we introduce them into our oxygen-rich atmosphere, things are going to start to happen. So we're going to be very, very careful. Actually, for many reasons, we're going to be very careful, but we'll have those sample tubes, once we collect them, contained in multiple layers of containment, partly just to keep us safe in case there is something that might be in there that we don't want. But we're going to keep it all very safe and contained. And then once we get it here, we'll keep it in an environment that's very similar to Mars, so that when we open those sample tubes, they don't have any adverse reactions, that we're going to make sure that we can extract the science that we want from those samples.
Understand. Maddie?
Yeah, we got another question from social media. What is the type of samples that the rover is capable of analyzing and recognizing?
So the samples that the rover itself is going to analyze, again, it can look at the rocks in general using imaging. It can use broad-scale imaging, microscopic imaging. We're going to laze some of them with lasers and make little plasmas that we can observe. We've also got X-ray imagers that can look at the rocks and get us the information. And again, we'll use all of that to help us pick where we want to take the samples. And then, as Dr. Z says, we've got really sophisticated equipment here on Earth. We want to get them back here where we can do the final analysis.
Is the water included in that as well? So anywhere like those channels exist, as Dr. Z mentioned, is it going to evaluate those channels as well and look for signs of?
It will, yes. And in fact, we're going to a really special place on Mars, because we know that in the past, Mars was warmer and wetter and had a higher density atmosphere. We know the climate changed over time, but that in the past, 3.5 billion years ago, it was warm and wet, and there was a standing body of water in Jezero crater where where we're going. And a river flowed into that lake, and when it flowed in, it dropped its sediment onto that floor of the crater, leaving a delta, just like we see here, where rivers run into oceans and lakes. And so those will be very, very important. That particular geologic feature is very important because that is exactly the kind of place you could preserve those early microfossils of potential life that, if it were there, this is exactly where you would find it.
I understand.
Yeah, so we'll do one more question from social. Why was the crater chosen as the landing site for the rover?
So I think that's a great follow-on because that's kind of what I was just talking about. We chose it specifically because we believed that the conditions about 3.5 billion years ago had all the pieces that you need for life to form. We had water, we had thermal energy because it was warmer, and we had the nutrients there from the soils and from the environment. And those are the key pieces that we need for life to take form. It's also about the same time that life started to form on Earth. And so we think at that time it's possible, if the conditions were right, that life would have taken hold on Mars in that area. And that river delta is actually feeding a large catchment area, much broader than that crater itself. So it's bringing in all of those materials and depositing them right there in that delta. And so if life were present, it should be preserved in that environment and in that geologic feature. So that's why we chose it specifically, because if we're going to look for evidence of past life, this is the kind of place you would want to go.
Quick follow-on, and do we have an indication as to why it used to be warmer and wetter and it's not now?
Oh, that's the million-dollar question right there. It's really a fascinating question why the climates change on the various planets. We see it on Mars. We've also seen it on Venus, another planet nearby, and on Earth we've seen evidence of past climate changes, and of course we're living in a time now where we're witnessing some changes. So understanding exactly what drives those climate changes is a really important question. It's not necessarily the focus of the Perseverance mission, but it's something that many of our other missions to Mars are focused on and trying to understand the answers. What is it that actually drives those changes?
Completely understand. I am going to tell you that that's more like a $10 million question, not a $1 million question.
Yeah, it's probably a $1 billion question.
yeah, that's actually more like it. Well, Lori, wow. I think that it would be such a journey just to step inside your head for a second and explore the things that you know or the things that you've seen and studied over your time. And it is just fascinating just to learn and understand like how life actually began. Like, I mean, it's like we're going back in time, and how amazing is that? And so, we definitely want to thank you so much for coming out here and sharing that with us. All it does is it makes this mission even more exciting, and we can't wait to see, in 2031, God willing, what we're going to find out about what's going on in Mars. So thank you again for coming over here and sharing that with us. So in closing, folks, please keep you can definitely keep your questions coming, and we'll do our best to to get you some answers on all of that. We want to thank Dr. Z and Lori for coming out here and sharing all of this with us. Please stay tuned. We have the 12 o'clock briefing coming for the mission. So tune into that if you have an opportunity. And Countdown to Mars. It's an exciting thing. It's coming, and we hope that you can be part of it. All right? So thank you again for joining us today. We hope you guys have a good one. You'll see our schedule for the rest of the day in just a moment here. Please tune in for our other shows that we have coming up on our virtual NASA lineup, and we'll see you guys soon. Thank you.